Hello everybody, my name is Joey Wham, and in this video I'm going to briefly talk about a neat way to sort values in an array. There are many sorting algorithms that serve different purposes, but today we're going to focus on insertion sorting. This algorithm is one of the easier ways to sort numbers in an array. It works well for small arrays or large arrays that are almost sorted. Insertion sort works similarly to the way you sort playing cards in your hand. A randomly shuffled deck of cards is given to you. You want to sort the cards from lowest number to highest number for easy finding during gameplay. You compare each card to the previous card in the deck to see which one is higher. The deck of cards is essentially split into a sorted and unsorted part. You look through the values from the unsorted part and place them into the correct position of the sorted part. By the end of your sort, you should have the lower cards to the left and the higher cards to the right in order from smallest to largest. Imagine how long it would take to sort an entire deck of cards this way. Let's take a look at the code involved in insertion sorting. This simple function starts by initializing three integers, I, j, and key. Next, a for loop goes through every value of I, starting at the second index. You can see that in the for loop I equals 1. Within the for loop, key is assigned to the value at index I. The key is essentially the value that is compared to other values in the array. And j is assigned to I minus 1. Next, a while loop occurs if and only if j is greater than or equal to 0, and the value at j's index is greater than the key value. If the while loop initiates, the value after j is set equal to the value at j's index. The value after j happens to be the key value. Fear not, this value is not lost since the variable key holds the original value of this index. Then, j is decremented by 1. This loop continues to run until j becomes less than 0, or the value before j is less than the key value. Finally, the index where the key value belongs is inserted. To help you visualize how this function works, let's look at a simple example with an array of size 5 that contains the numbers 8, 4, 12, 9, and 2. The first two numbers looked at are 8 and 4. 4 becomes the key value and is compared to 8. Since 4 is less than 8, 4 is inserted into the second index and 8 is inserted into the first. Now 12 is the value being compared. Since 8 is less than 12, the while loop does not initiate and the next index in the for loop begins. Now 9 becomes the key. 12 is less than 9, so they switch indexes. The last number in the array, 2, becomes the key. Just by looking at all the other numbers in the array, we can see that 2 is the lowest number. Since 2 is less than 12, 12 is inserted into 2's index. Now j equals 2 at the value of 9. Since 2 is less than 9 and j is greater than 0, 9 is inserted into the fourth index where 12 originally was. Then j becomes 1 at the value of 8. 2 is less than 8, so 8 is placed in the third index. Next, the key value 2 is compared to the value at index j equals 0. Still, j is greater than 0 and 2 is less than 4. So, 4 moves into the second index and j is decremented once again. However, j is now less than 0 and the while loop ends. Finally, the key value of 2 is inserted into j plus 1, which is 0 in this case, at the first index. Since this is a data structures class, it is only right that we talk about time taken, space, and stability. The best time case for insertion sort is O of n. O of n means that every value of an array of size n is iterated over. This occurs when the list is already sorted and the while loop never runs. The worst and mostly average case is O of n squared. With a randomly sorted array, you must at a minimum check every index of the array. Chances are the array is not sorted. Therefore, at each index, you may have to check every index before the key value to ensure the array gets sorted properly. This array sorts in place. What this means is that we can sort without any extra space required, or an auxiliary space of O of 1. Once the array is made, we simply move indexes around until the array is in numerical order. This type of sorting is stable. This essentially means the algorithm preserves the order of records with equal keys. Now, what does that mean? The key value and the j value in the algorithm appear in the same order in sorted output as they appear in the input array to be sorted. This helps to avoid small magnifying errors. To summarize this video, insertion sort is best used for arrays of smaller size. The time taken to sort smaller arrays compared to larger arrays is substantially better. This algorithm is short and easy to implement. It is stable, sorted in place, and requires no extra memory. This is an excellent algorithm for beginners to grasp and use as a foundation to gain a better understanding of other, more complex sorting algorithms. Thank you for watching my video, and have a good one, guys.